So here we'll look at another interesting limit problem. The question is find the horizontal asymptotes of this function, right? So let's so that means we have to investigate behavior. So for horizontal asymptotes, right? So basically what they're saying is how does this function behave as t goes to infinity, right? So this can be interpreted as the limit of f of t as t approaches infinity, both positive and negative infinity, right? Because we need to figure out what happens in both ends of the spectrum, right? So let's start with the limit. So let's say the limit of f of t as t approaches infinity, right? So that's the limit of e to the t over 1 plus minus t as t approaches infinity, positive infinity, right? So this is interesting, right? So we can just we should rewrite this as e to the t over 1 plus 1 over e to the t, right? Because we can rewrite e to the minus t as 1 over e to the t, right? Now we can see that as t approaches infinity, this term, so change color, so this term approaches 0. Sorry, yeah, right? So because as t gets bigger and bigger and bigger, we divide it more and more, and this we get smaller and smaller, this approaches 0, right? So this actually behaves as, this is equal to, this behaves as e to the t over 1, and we know as well this goes to infinity, right? Because e to the power of anything is, it's a huge number, and e to the power of infinity is a huge number, infinity, right? So this is just this approaches infinity. So this is unbounded. Unbounded as t approaches infinity, positive infinity, right? Okay, so now we're going to look at the limit of f of t as t approaches in negative infinity. So the limit as t approaches negative infinity of e to the t over 1 plus e to the minus t. Now we're going to do the same thing here, right? We're going to do the same thing. So zoom in. All right. Do the same thing here. So we're going to rewrite this as e to the t over 1 plus 1 over e to the t. Now we're going to negative infinity, so either way it doesn't really matter. This is going to be a smaller and smaller and smaller number. All right. So this is gonna go to 0. Well, okay, let me just rewrite this, right? So this is e to the t, okay? So we're going to negative infinity, right? So let's, for this, like, so we need, I mean, this is not, you technically can't plug an infinity in because it's not really a value, but for the sake of this problem, we can just say it's negative infinity over 1 plus 1 over e to the negative infinity, right? And this is the same as 1 over e to the infinity divided by 1 plus 1 over e to the infinity, which is just 1 over e to the infinity over 1 plus, we just flip this around, e to the infinity, right? And then we can pretend this 1 is not going to do anything as we go to infinity, so this is just going to be 1 over e to the infinity divided by e to the infinity, and this goes to 0, So this part goes to 0. So this is just 0 divided by some e to the infinite number, right? Which is just 0. Okay. So it is an asymptote at 0, right? Horizontal asymptote at 0 as we approach negative infinity. But as opposed to positive infinity, it's unbounded. It just goes on forever. Okay. I hope that makes sense.